Okay, continuing on today with our Laplace transform playlist, we want to find the Laplace transform of f of at, and we just have this condition that we want a to be greater than 0. I did think about when doing this, I don't actually use this formula very much. It's still kind of nice, it's interesting, and it's not very hard to derive this, so I thought we could do a video on this really quick. To get started with this, I'll just go back to our definition for the Laplace transform. So we'll write this out, and now instead of having f of t, we're going to have f of at dt. But then in order to handle what we have going on here, I can just do a u substitution to simplify this. So let's say we'll call our u equal to at, and I think the way I'll do it, let's solve for t, 1 over a times u. Take a derivative, so the dt value is just going to be 1 over a du. Okay, now first updating our bounds, plugging in infinity here. Well, we've already said that our a is greater than 0. So if a is greater than 0, then this part's still going to infinity. And then we plug a 0 in here, lower bound 0. Then next here, in for t, if I plug in 1 over a times u, just a slight rearrangement on this, I can write this as e to the minus s over a times u. This is just going to become f of u, and then dt becomes this. We'll write it as du, but I'll take the 1 over a as a constant and bring it up front. But now at this point, what we have here, this is just a Laplace transform. We've got the bounds set up from 0 to infinity. We have an f of u here. The variable now is u. We could change this back to t if you're more comfortable, but the variable name doesn't really matter in a definite integral. And now, like, our input on this is just this s over a. So from here, I can just go to our formula for this. We have 1 over a in front. And so for this whole thing, we can write it as our big F, our Laplace transform, but the input changes, it's just going to be s over a. And just a quick note on this formula, again, we need this condition that a is greater than 0, but we still need our condition of a regular Laplace transform, so we still want s to be greater than 0, and we still want our f of u or our f of t to be of exponential order so it doesn't blow up faster than the exponential. We have these conditions just so that we're sure this integral converges. Okay, so now that we have this formula, let's see a quick example of this. Okay, so now we have our example. It's just the Laplace of cosine 3t. And you'll notice we don't need this formula for this, because we already did a cosine of at, so we have a formula for cosine of 3t, and we could find it that way, just as easier. So we're just doing this example to demonstrate the formula. So to use this, what I'm going to do, we'll call our a value just this coefficient here, so we'll say our a is 3. So just to make it clear, our f of at value is cosine 3t. So taking away the a, our f of t that we're looking at is cosine of t. So to set up this formula, instead of getting our f of s over a, if we just want our big F of s, we just want the Laplace transform of f of t. And so in this case, this is just going to be, we just want to find the Laplace transform of cosine of t. So let's say that we already know this value. This is actually just s over s squared plus 1. But now that we have this, we have our big F of s value, we have our a value, so we can just go ahead and use this formula. So plugging in for a, we're going to have this going to be 1/3. And now for this piece, we just need to plug in s over a as our input into this function here. So what we're going to have is it's just going to be s over 3 in the numerator. And then here for s squared, it's going to be s over 3, inputting that, squaring it, plus 1. Then let's just simplify this a little bit. So I'll leave this. Multiplying this out, this is going to be s squared over 9 plus 1. Then what I'll do to clean this up, let's just multiply by 9 over 9, multiplying by 1. So then coming down here, 9 times s over 3, this is going to give me 3s. Then here, the 9s are going to cancel and just going to be s squared plus 9. But then I can cancel 3's here, and so we'll get our final solution here, just s over s squared plus 9. And then you'll just notice this is the same thing you would get if you just used our formula for the Laplace of cosine at. So there you have it, Laplace transform of f of at. Thanks everyone for watching. Have a good day.